Dear viewers, today I am gonna show you DAB converter, dual active bridge converter, developed by DAB Electromet Private Limited. This system rating is 1 kilowatt. Okay, so this is the scheme of the DAB converter. Okay, this is the gate pulses sections. This is the controller. Okay, now you can see here we have given the 3-phase diode rectifier. Okay, in our input capacitor, input voltage sensor, input current sensor. This is the full DAB converter. Okay, primary bridge, it is known as the bridge 1, secondary bridge, which is known as the bridge 2. Okay, this is the high frequency transformer, LCM inductor. Okay, this is the output capacitor, output voltage sensor, output current sensor, and here you can connect the load. So now you can see this system is the 1 kilowatt system. So input voltage is 400 volt DC. At the output we can maintain 50 volt DC. Okay, so 1 kilowatt, so you can maintain here the load is 2.6 ohm only. Okay, so you can reach the 20 ampere current at 50 volt, so your power rating will be 1 kilowatt. Okay, and this voltmeter is connected at the output of this rectifier, means at the capacitor side. So 40 volt we can see here on the meter 1, and on the meter 2 we can connect this at the capacitor of the output side. So you can see here the output voltage, and here at the load side we can connect the current meter, so we can measure the current, output current. Okay, and this is the controller. So now you can see the connection diagram. As you can see in this figure, RYB, grid voltage, you can connect through the auto transformer. So you can vary your input voltage gradually through the auto transformer and maintain DC voltage here at 400 volt. Okay, so 3-phase grid you can connect to the auto transformer, and the output of the auto transformer you can connect here. Okay, and after that plus VDC and minus VDC is here. So plus VDC is connected to the capacitor positive, minus VDC is connected to capacitor negative, and you can connect the voltmeter. Okay, input voltmeter. So plus VC to plus VHV sense, minus VHV sense. Okay, and also you can connect plus VC to IHV sense. Okay, plus IHV sense, and the minus IHV sense we can connect to bridge 1 positive side. So plus VDC input side. Okay, and you can connect the negative link to plus minus VC to minus VHV sense to minus VDC in. Okay, internally all the bridge DAB converter is connected. Okay, so output of the DAB converter you can connect with the sensor input, current sensor input. Also you can connect with the capacitor, positive, negative. Okay, and the negative of the capacitor you can connect with the negative of this voltmeter, and here positive VC is connected with the positive VLV sense side. Okay, and you can connect the load between this negative VLV sense and the negative ILV sense. Okay, in between that you can connect the load which is 50 volt 20 ampere withstand. Okay, so if you can connect the resistive load, then here you can connect the resistor at 20 ampere and 2.6 ohm only. Okay, this is some sensor calibration detail. Okay, so HV side 500 volt to 3 volt average, HV side current is 15 ampere to 3 volt average. Likewise this you can connect the sensor calibration, and also how you can connect the sensor output. Okay, so here we have given the sensor output. Okay, so sensor output you can connect with the ADC of this controller. So which pin you can connect here, which is mentioned clearly here: PA3, PC0, PC1, PC2. Okay, and this is the some key functions which is used in the open loop and closed loop system for PD6. PD7 is used to turn on, turn off, PD3 is used in. If it is on open loop, then PD3 and PD4 is used to phase shift increment decrement, and if it is in closed loop, system is in closed loop, then PD3 and PD5 is used in to increase and decrease the VREF value. Okay, so here you can see PD7, PD6, PD5 and PD3. Okay, and also you can connect the gate pulses connector like here, like this. Okay, and all the gate pulses you can connect here, GA, GA dash, GB, GB dash for the bridge 1. So GA, GA dash, GB, GB dash for bridge 1 gate pulses, all the 4 gate pulses, and GC, GC dash, GD, GD dash for bridge 2 gate pulses. So it is GB, GC, GC dash, GD, GD dash secondary bridge gate pulses. Okay, and 5 volt and ground. So carefully connect the 5 volt and ground to the controller. Okay, and here you can see the high voltage side sensor output. You can connect ADC. Low voltage side sensor output you can connect at ADC. Okay, and also you can observe the primary current and the secondary current. Primary side current transformer current and the secondary side transformer current you can observe here. Okay, both ground is isolated, so you can connect once at a time if you have an non-isolated DSO. Okay, if you have isolated DSO, then go with this both. Okay, so here you can see the output of the CT. Okay, this is the driver status. Okay, now we have turned on the system. Okay, so you can see once everything is perfect, okay, then means no fault is there in the bridge 1 and bridge 2, then this ready LED will indicate ready LED is indicating. Okay, all the pins is green. Okay, if anything happen in the bridge 1 or bridge 2 switches, this fault LED will glow. Okay, red LED will glow. Okay, at that time you can just turn off all the system, turn off 0 volt. You can set here to auto transformer, wait for some time to discharge all the capacitors. Okay, and you can just press this reset button, then after you can restart your system again. Okay, and now you can see, okay, now you can see the display. So open loop mode, reference duty means phase shift is initially is 2%. The system is off. V0, I0, V in and power we can observe from here. Okay, also you can see by pressing this button, you can see it is toggle into closed loop mode. VREF set here is 50%, 50 volt. Off mode, V in, I in, V out, I out and power. Okay, also you can see when I am pressing this, it is increasing the VREF value. When I am pressing this button, it is decreasing the VREF value. Okay, it is in open loop mode. Okay, okay, if it is on, okay, then you can also observe the phase shift in the closed loop mode. Okay, but you can see once this pulse is on, you never toggle in the closed loop to open loop or open loop to closed loop mode. Okay, and also we have provided many protections. If it is something happen in the high voltage side bridge, okay, over voltage or over current is happen, then this LED will change and it will show the voltage, high voltage side current and high voltage side voltage protection is active. Also we have given the protection for the low voltage side over voltage and over current protection or over power protection we have given. Okay, so in the next video we will see the gate pulses and operations. Okay, thank you.